Hello friends, in this video I am going to show you the 4 important questions for the GATE 2024 on subject of signals and systems. These 4 important questions are very useful for the students who are preparing for GATE 2024 and studying in ECE and EEE branches. In that, the first question is, which of the following can be the impulse response of causal system? Here we need to find the impulse response of a causal system. Before solving this question, first we have to know what is meant by causal system. Causal system is nothing but the system whose impulse response is present only in the positive time axis. That system is called causal system. Here observe, we have 4 options. On which option the impulse response only present in the positive time axis? Observe, at option A the impulse response is present on both positive and negative time axis. So option A is not correct one. In option B, the impulse response present in only the positive time axis. So the option B is correct one, because for the causal system, the impulse response should be in the positive time axis only. And at option C, the impulse response here, impulse response is present in both time axis, that is positive and negative. So option C is also not a correct answer. Now coming to option D, it's also not a correct answer, because here the impulse response exists in negative time axis. So the answer is option B. This question can be asked like this also: what is the impulse response of non-causal system? They can ask like this also: what is the impulse response of non-causal system? If they ask like this, first we have to know what is non-causal system. Non-causal system is nothing but the system whose impulse response present in both positive and negative time axis. That system is called non-causal system. Here option A and option C are the correct answers for the non-causal system, because at option A and option C the impulse response is present in both positive and negative time axis. And one more question also there, that is, sometimes they will ask, what is find the anti-causal system. Anti-causal system is nothing but the system whose impulse response is present only in the negative time axis. It is exactly opposite to the causal system. Anti-causal system is nothing but the impulse response is present only in the negative time axis, then that system is called anti-causal system. Here option D is the example for anti-causal system. Okay, it's about the first question. Now coming to second question. Here the Dirac delta function is defined as. First, we have to know what is meant by Dirac delta function. Dirac delta function is also known as impulse function. Here observe, impulse function should be like this, that is, it is time axis and it is the amplitude axis, it is del of t. Here impulse signal like this. Impulse signal is existing only at the time t equal to 0, having amplitude as infinity. Okay, remember, impulse signal is having the amplitude as infinity. Impulse signal is also known as Dirac delta function. Okay, now coming to the option, the first option is del of t is equal to 1 when t equal to 0. That is, at t equal to 0, the amplitude is 1. No, because for del of t, the amplitude is infinity at t equal to 0, but at the option A they have given amplitude is 1 at t equal to 0. So option A is wrong one. Now coming to option B, del of t is equal to infinity when t equal to 0. Okay, here at t equal to 0 we have infinity. Okay, option B is correct one, but we have to verify option C and D also, then only we can conclude option B is correct one. Option B is somewhat correct one, because it is having the amplitude infinity at time t equal to 0 and 0 otherwise. Now coming to option C, that is del of t is equal to 1. Okay, del of t is equal to 1 when t equal to 0. Okay, it is wrong one, because at t equal to 0 the amplitude is infinity. Now coming to option D, del of t is equal to infinity and t equal to 0, 0 otherwise. Up to this correct one. Now coming to second condition, integral minus infinity to infinity del of t dt equal to 1. It is also a correct one. If we integrate from minus infinity to plus infinity for the Dirac delta function, it should result the 1. Okay, these two conditions are true. So the correct answer is option D. Okay, option D is the correct answer here because it satisfies the both the condition. Option B is also correct, but when compared to option B, option D is correct because option D satisfies two conditions of Dirac delta function. Now coming to the third problem, that is the function x of t is shown in figure. Here they have given the x of t function. Even and odd parts of unit step function are given below. Here we have to find the even and odd parts of the unit step function in terms of x of t. Here observe x of t is nothing but signum function. Okay, x of t is nothing but signum function. Here this function is nothing but signum function. Here what is the question means? Here we have to find the even and odd parts of unit step function in terms of signum function. Here I will give the formulas for finding even and odd parts and you will do, and I will say the answer, exact answer, and verify whether you are doing correct or not. First, for finding the even part of unit step function, that is UE of t. UE of t is nothing but even part of unit step function, that is u of t plus u of minus t by 2. It is the formula for finding the even part of unit step function. For finding the odd part of unit step function, we have another formula, that is u o of t. O of t is nothing but odd, equal to u of t minus u of minus t by 2. It is for finding the odd part of unit step function. By using these two formulas, you will find what is the answer. Then I will give you the answer first. Here option A is the correct answer. Even part should be 1 by 2, odd part should be 1 by 2 into x of t. You will do by using these formulas and verify your answer is correct or wrong. Okay. Now coming to the fourth question. It is coming to fourth question. That is a discrete time signal, that is x of n is equal to sine pi square n, where n being a integer. Now we have to find whether the signal is periodic signal or aperiodic signal. If the signal is periodic signal, then what is the period of a signal? We have here four options. First, compare our given signal with the standard discrete time sinusoidal signal. The standard discrete time sinusoidal signal should be like this, that is sine 2 pi fn. Okay, it is the standard discrete time signal. Here compare our standard discrete time sinusoidal signal with a given signal, then we can get 2 pi f. 2 pi f is equal to pi square. Here in place of 2 pi f, here we have pi square. Pi, here pi and here pi get cancelled, then 2f is equal to pi. Now f is equal to pi by 2. Here we get the frequency, that is 5 by 2. We know frequency is the reciprocal of time period. So the time period t is equal to 2 by pi. Okay, time period is 2 by 2, 2 by 5. Always remember the time period should be in terms of integers only. Okay, there is no imaginary part, there should be not even single imaginary part or a single pi component also. The time period of a periodic signal should be in terms of integers only, but here observe it should not be in integers. Okay, here pi also included, so we can say this particular signal is not a periodic signal. So the option D is the correct one, not periodic. Okay, option D is correct one, because for periodic signal the time period should be in terms of integers only. Okay, there is no pi should not be included, and there should not be any imaginary part also. So here the signal is not periodic signal. Okay, I hope you understood these four questions. If you have any doubts, let me know in the comment box. I will surely answer to your comments, and if you want to know a few more topics, or if you have any doubts on GATE 2024, I will give you my personal mail and telegram channel in the description box. and ask the questions through mail or telegram channel. Thank you for watching this video.